Hey guys. All right, week 2 of science. Last week we talked about what energy is, and this week we're going to start talking about specific kinds of energy. This week it's going to be sound energy, and we are going to know what sound energy is and how it's produced. All right, so sound energy. It says the blare of an alarm clock, the beep of a car horn, the quack of a duck, and the rumble of thunder during a storm are all sounds. Sound is energy in the form of vibrations passing through matter. A vibration is a quick back and forth movement. Sounds occur when objects vibrate. Sound can travel through solids, liquids, and gases, but sound cannot travel through empty space where there's no matter. So that means in space, can't hear anything. That's why they've got to use microphones and talk that way through spacesuits if people go to space. Matter is needed for sound because collisions between particles and matter can cause some energy to be transferred into the air. The air gets heated and then the sound is produced. If you pluck a guitar string and the string starts to vibrate, the vibrating strings collide with the particles in the air around it and pass energy to the air. The sound energy travels outward as sound waves. A sound wave is just a disturbance that moves sound energy through matter, which is solid, liquid, or a gas. When the waves reach your ears, the waves then make your eardrum vibrate, and you hear the sound made by the guitar string. So that's why sometimes if something is too loud, it hurts our ears. That means that your eardrum is vibrating too quickly, and that's why sometimes if we hear loud music, we kind of go like this. That's why, because it vibrates your eardrums. All right. See, it's so much faster if we just had our books in front of us and we could talk about it that way and not wait for the page to turn on a website. All right, how does sound travel? So, as sound waves move through matter, they set particles into motion. The moving particles then form a pattern. Areas with groups of particles that are bunched together alternate with areas of particles that are further apart. So, it's kind of like a pattern. So, close together, further apart, close together, further apart. The areas where the particles are bunched together are called compressions. Sound waves travel at a different speed through matter. So sound waves travel quickly through most solids and liquids, and they tend to travel more slowly in gases. So I want you to look over here at this picture of the drum, and then we've got the sound waves coming off of it. And it's showing that alternating pattern of close together, further apart, close together, further apart, which here represents the compressions. Right, very good, because it says right here that, all right, that compressions, is it going to let me do it? The areas where particles bunched together are called compressions. So which areas here are going to be our compressions? Right, very good. Uh-oh. All right, let's see here. Maybe I'm going too fast. Okay, very good. All of these areas right here where they are close together are going to be our compressions, and then they've got the places in between that are further apart. Very good. So sound, recap, can travel through solid, liquids, or gases, but it cannot travel through empty space where there is no matter. It goes as vibrations, and that's why we can hear things, because it comes into our ear and then vibrates our eardrum so that we can hear that sound, whether it's a guitar string, someone knocking on the table, clapping their hands, snapping their fingers, or even just talking. All right, that was a quick day one. This is a quick lesson this week, but we will finish it up tomorrow. All right, guys, have a great day, and I will see you tomorrow.